All right, guys. So next topic that we're going to get into is something called a polar coordinate or polar curves, and this is polar graph paper right here. This is polar graph paper right here, where you don't really have the rectangular grid anymore. Now it's more spiral grid, which I'll talk about in a second. Um, so, a couple things when you're doing this. All right. First off, you have your polar axis, which is right there. Everything starts from here. So if we go back to trig and your unit circle, this is basically unit circle type stuff. So your polar axis, you have your origin. They call it the pole, right? And that's just your initial side. And then what we're basically doing is just drawing angles. So you could see here I have theta is drawn, and then I have a terminal point and a radius. Okay, so now instead of writing things as xy, we write them as r's and thetas. R's and thetas. So, for example, if I was doing like any angle that we want, we're going to have a terminal point, meaning we're having a distance where I kind of like to call it the radius because it's circular, but it's radius and theta. So you're going to be giving things with distance and angles, just like on the unit circle. So, I mean, it really just comes down to drawing angles and having your initial side. So we'll get down to the examples in a second. A couple little things that we should go over. The angle is positive, you are going counterclockwise. If the angle is negative, you are going clockwise. And R can be positive or negative. Actually, let me show you the difference. So say R is positive. Your angle, so you always start with your initial side. Angle goes out, and R is positive. That one's the obvious one. Now, if R was negative, you still are starting in the same initial side. Angle comes out. But because R would be negative, it actually winds up going back. So instead of going this way, it goes like 180 degrees backwards. So you can see that was where it was, and now R is going back. So it's actually that direction there. So that would be your graph if R was negative. Let me show you a quick little example. Now, I know you guys might have this graph paper or might not, but if you do, that's great. If not, you could always just draw it on the grid and just make sure you show which quadrant it's in, okay? So again, you're not really labeling these as X and Y anymore. All this is, for example, that would be zero. This would be 0, right? If we're breaking it up, this is pi over 3. No, my bad. Pi over 6, right? Pi over 3. And then you have pi over 2, and so on. Okay, so, for example, if we're doing 1, 2 pi over 3, 1 is your R, and theta is 2 pi over 3. And you can see here, like 2 pi over 3 would be this one. These little marks are like your radius, 1, 2, 3. So you start on your initial side, and you go over 2 pi over 3, and you just go 1 unit up. So this point would be 1, 2 pi over 3, and you can see the angle here is 2 pi over 3, and your radius would be 1. So it looks like that. So it would be just really that point. This is the point 1, 2 pi over 3. Now if you had a negative angle, like we were talking about before, still starting on your initial side, and now this time you are going negative pi over 4. So negative pi over 4 would be, let's see how many we have. 1, 2, 3, 4, 5, 6, 7, 8, 9. It doesn't really, so it has to be like 4.5. So it's going to go down, and it'll be this way, right? But you don't really need the arrows here. You just want to make it a terminal and make it end. So go right in the middle here. If that was pi over 4, and we're going 3 units, so if it's 1, 2, 3, that would be the point. So that is 3 negative pi over 4. Rear angle, negative pi over 4. Radius is 3. But that is the point